this video I will show you a new inverse tree and a particular case of ambiguous tree derivation using OR AND tree. Well, first of all, just take the typical example with some dumb rules, like an useful rule that we can use just because we want that our proponent won. That's the typical case that we use so far. And the proponent won. It's okay. What happens if I put a defeater, and that is the only rule that can change our flies bird divisible rule. What happened? Well, it's easy. The first tree derivation fails, so start the opponent tree derivation, and after that we have opponent won, so it works and it's okay. But if we want to switch to a particular example in which proponent and opponent have got different number of rules, in particular we have a match point rule. Flies becomes strict, and so there are some branches in which seek activates the defeater, and so the opponent wins. But in branches where flies strict is activated, obviously we have the opponent that won, that wins. But as the number of rules is different, the branches will have a different kind of rules in their propagation. So it became important, the definition of the kind of tree to use to derive our argumentative debate. Using OR AND, in particular, we have an AND as we pretend that all the elements of the list returned by the findall are able to get the one proponent. So 1, 2, 3, 4. What happened? Opponent won. That sounds strange. Well, we didn't use in opponent won the OR AND, but the OR tree, and so it's so that there is at least one branch in which the opponent can win. Indeed, the first tree derivation fails. Proponent won strict, but not always, and so, for example, here it didn't win, and so it stops. But if we change this simple rule from AND to OR, now proponent won. It means that change the semantical meaning of this tree. Using this clause, we say that we want that in our tree we always win. In this case, we say I want to see if at least one time I win. Okay, bye bye.